to finish talking about symmetry, let's look at how symmetry can be checked through an equation instead of a graph. So for the first example, we're going to use y equals x squared minus 3. Okay, so it is a parabola, but we want to say if it is symmetric to the y-axis, the x-axis, or the origin. So to check for the y-axis, remember we said that that was the case when f of x is equal to f of negative x. So in other words, we're putting in the opposite of x for x and seeing if it's the same equation. So let's test it out. Y equals, put in the opposite of x, and keep everything else the same. Okay, then evaluate that. So y equals negative x squared means a negative x times a negative x. That's two negative signs. So they do eliminate each other. So that's just x squared minus 3. Okay, now compare that to the original equation. See how it is exactly the same on both sides? So that is a yes. Okay, it is symmetric to the y-axis. Now, really, it's a parabola, looks like this. You could stop right there. You don't really need to check for symmetry across the x-axis or, oh, I know that is not accurately graphed. Check for symmetry across the x-axis or the origin, right? Because you can tell from the graph, you know what it looks like. But let's say you don't. Here, I'm going to graph it a little bit more accurately, right? It's x squared minus 3. To check for the x-axis, okay? To check for the x-axis, we're going to be checking is the f of x equal to the opposite of the f of x. In other words, put the y value in as a negative. So negative y equals x squared minus 3, going back to the original equation every time, okay? And so now we have to compare that to the original. It's probably pretty obvious that they're not the same, but to show that, multiply both sides by negative 1. And that would be the whole side here. So therefore, negative 1 times negative y is y. And then multiply the negative 1 to each term, negative x squared plus 3. Notice that no, those are obviously not the same equation. It is not symmetric about the x-axis. Finally, the origin test. Remember, the f of x would need to be equal to the opposite of the f of the opposite of x. So we're going to want to put a negative x in and a negative y in. So negative y would equal negative x squared minus 3. For the x, when I'm squaring, when I'm doing something to the x, always use a parentheses around that to show how it works. So let's see if we can evaluate that a little bit. So negative x squared would be x squared, still minus 3. Now we want to do what we did for the second test and multiply both sides by negative 1. Okay, to get that y to be alone so we can compare the equations. Okay, so when we look at this equation according compared to the original, not the same. So that it is not symmetric about the origin. So you would state that this was symmetric about the y-axis, and really the work you would show you could just show the first work. You wouldn't have to show the other tests. All right, here's another example. It's kind of a challenging one. I want you to be able to understand the hardest ones. So y equals 4x squared plus 1 divided by 3x. Okay, so we could try all three tests, the y-axis, the x-axis, and the origin. But I do want to just jump right in and show you why it would be the origin. So we're going to start with the origin test. And if that test works, then we're not going to do any other test. All right, so remember for the origin test, it's f of x is equal to the opposite of the f of the opposite of x. So plug in an opposite of y, negative y, and then plug in the opposite of x for both of those x's. Okay, Now to evaluate, I think we should evaluate what we can on the right side first. So that would be 4x squared plus 1. And at the bottom, 3 times negative x, so negative 3x. Now we're going to get that negative away from the y by doing the same thing we did before, multiplying both sides by negative 1. Okay, I'm multiplying there. All right, so this negative will cancel, so that's y equals. Now on this side, this is where it's a little bit interesting. The negative 1, and then there is a negative 1 here on the bottom, a negative 3, right? So this negative 1 and this negative sign will cancel each other out. So at the top, we still have 4x squared plus 1. On the bottom, we have 3x. Notice that that is the same as the original. So in other words, f of x equals the opposite of f of the opposite of x. So this is a yes, and it's symmetric about the origin. Okay, you can do the other tests and they will not come out to work, but I want to save you the time there. Okay, so if you suspect it's symmetric about a certain way, do that test first and then you can kind of stop. All right, thanks for watching.